exact area, and then we will choose an interval, and then we continue. Any function? Do I choose one? Okay, what about 2x squared minus x plus 8? This is quadratic. So now let's choose an interval. So we want to determine the area under the graph of this function between this and this. Now, if you choose any number but 0, it will be slightly more involving. But it's just algebra, so it doesn't matter. So just give us an interval.
0 to 3.
Yeah, that's good. But I think we should see one that does not start at 0.
1 to 4.
1 to 4. Very good. Perfect. So remember, we have 3 preps. The first prep is delta x. Delta x is always, so the interval, remember, it's a comma b. So delta x is always b minus a divided by the number of subintervals. It's the length of the interval divided by the number of subintervals. And that will give us the width of each subinterval. Is that clear? Okay. So in this case is 3 over n. Agreed? Okay, now the second prep is xi. So let me refresh your memory on what xi means. So this interval is between 1 and 4. So my x1 is 1 plus 1 delta x. My x2 will be 1 plus how many delta x? 2. And eventually I get to xi. What will xi equal to? 1, because that's the leftmost point of the interval, plus how many delta x's? If 2 had 2 delta x's, if 5 had 5 delta x's, xi must have I delta x's. Because if I is 4, then this is 4. If I is 10, then this is 10. Is that okay so far? Matt, is this okay? Yes, everyone? Okay, now the third prep is f of xi. I have to plug in, oh, I'm sorry, I didn't finish, sorry. So this is 1 plus 3I over n. Because delta x is 3 over n. I copied it from number 1. So this is 1 plus 3I over n. Agreed? Okay, now here's the function. I have to plug this in instead of x. So I have 2 in parentheses 1 plus 3I over n squared minus, and I have to distribute, but let's write it with parentheses first, and plus 8. So this is f of xi, but it's not fully simplified. I have to fully simplify it first. When I square binomial, how many terms do I get? Please make me proud.
3.
Thank you. First term squared
1.
plus 2 times 1 times 3 over n times I, 6i over n, plus the second term squared, 9i squared over n squared. Do we agree with the first quantity? Now I distribute -1. -1 minus 3i over n and plus 8. Now I distribute 2. 2 plus 12i over n plus 18i squared over n squared plus 7, because it's -1 and 8, minus 3i over n. I present everything in descending order of powers of I. 18i squared over n squared plus 9i over n and plus 9. And this is fully simplified. Any questions? Any questions? Is this okay? So I see that there is a 9 in common. I would like to pull it out only because the numbers inside of the summation notation will be smaller. So this is 2i squared over n squared plus I over n and plus 1. So far, so good? Now I know that the area equals the limit as the number of subintervals, n, the number of subintervals that I divide the interval by, as n approaches infinity from the sum from I equals 1 through n. So this is I'm summing the areas of each rectangle. Delta x is 3 over n, multiplied by f of xi, which is this, 9, and in parentheses, 2i squared over n squared plus I over n and plus 1. Is this okay so far? Now remember, this does not depend on I, and it's a factor. So it's going to be 27 over n. I'm going to put it in front. So this is limit as n approaches infinity from 27 over n. And now I will have to apply the summation notation or sigma notation to each and every term. Sum of this term plus sum of this term plus sum of this term. So sum I equals 1 through n from 2i squared over n squared plus the sum of I over n plus the sum of 1. Now, like before, I will put in front of each summation or sigma notation the factor that does not depend on I. This factor does not depend on I, it will go in front. This factor with 1 at the top does not depend on I, it will go in front. So therefore, this is limit as n approaches infinity, 27 over n, 2 over n squared, the sum of I squared, plus 1 over n, the sum of I, plus the sum of 1. Any questions? Are we okay so far? Questions? Is this okay? So now this needs to be replaced, this needs to be replaced, and this needs to be replaced. What do I replace the last one by? That's it. What do I replace the middle one by? n plus 1 divided by 2. And the first one with I squared is n plus 1, 2n plus 1 divided by 6. So then limit n approaches infinity, 27 over n, bracket, 2 over n squared times n. It is wise to put this already multiplied in here. So this is 2n squared plus 3n plus 1 divided by 6 plus 1 over n times n plus 1 divided by 2 and plus n. See if this is okay so far. Is this okay? I will only simplify an n and an n from the first term. If I simplify by 2, I will get 3, but there is nothing I can do to this. So I'd rather keep it with the denominator of 6. So limit as n approaches infinity, 27 over n multiplied by 6n in the denominator. So here I'm just going to distribute. So I have 4n squared plus 6n plus 2. However, here I have to multiply by 3. And this one needs to be multiplied by 6n. So then plus 3n squared plus 3n plus 6n squared. So let's do this one more time together. So I distributed 2 to these 3 terms, and I got this. But here the denominator is 2n, but I really need 6n. So I have to multiply by 3, and I distribute n squared plus n, but multiply by 3. 3n squared plus 3n. And this one has denominator 1, so it needs to be multiplied by 6n, so that's how I get 6n squared. Any questions? I should simplify, and let's do that by 3. So the denominator is 2n squared. So I'm combining like terms now. 4n squared plus 6n squared is 10 plus 3 is 13n squared. 3n times plus 6n is 9n and plus 2. You can distribute now the 9. Uh, 18 and 2n squared. N squared. What is the answer? Same degree over same degree. I can use L'Hopital's rule because I have infinity over infinity, or give the answer right away. What would the answer be?
117.
Yes, so it's going to be 117 divided by 2, correct? Any questions? Any questions on how to determine the limit of the Riemann sum for a linear quadratic cubic? Any questions? Are we okay? Okay. Do we need another example? Yes? Okay, let's choose another problem. Any function? And now we can choose a interval that starts at 0, so we can move on, or whatever you want. Any function, please? And any interval. But again, linear, quadratic, or cubic.
X cubed minus 2x minus 9.
Minus 9? Very good. Perfect. Any interval? Now, if we don't start at 0, we're going to have to cube 1 plus 3i over n or something.
0 to 2.
0 to 2. Perfect. We need 3 preps. First prep is the width of the interval. Can anyone give us delta x?
2 over n.
Yes. Because we have n subintervals and the width of the interval is 2, each subinterval will have a width of 2 divided by their number. Good. Now, can anyone give us xi? And we will start at 0 plus,
Could be 0 plus 2i over n.
yes, I delta x, which is 2i over n. Perfect. And the final prep before we start the limit of the Riemann sum is f of xi, which will be f of 2i over n, which is 2i over n everything cubed minus 2 times 2i over n minus 9. I caution you that there is such thing as a negative area. It's possible. So it's okay. which means that the function has a more area under the x-axis than above the x-axis. So for example, if a function looks like this, let's say on the interval 0, 2, if it looks like this will be a positive area, and this will be a negative area. Obviously, when I add this tiny one to this bigger negative value, the entire area will be negative, which is okay. Okay? Good. So I have to simplify, and I get 8i cubed over n cubed minus 4i over n minus 9. Now I have all the pieces, and I can create the limit of the Riemann sum. So n approaches infinity from the sum from I equals 1, the sum of all the areas base times height, till the last one. And inside we have delta x times f of xi. Delta x is 2 over n, and f of xi is 8i cubed over n cubed minus 4i over n minus 9. Is this okay so far? So we only determined those pieces, and now we are putting them together. Is this okay? So again, I'm going to take this constant outside. It's a constant, it's a factor. That's why I'm allowed to put it outside. So this is limit as n approaches infinity from 2 over n. In order to save some time, when I apply the sum to this first term, I'm going to take 8 over n cubed outside and say the sum of I cubed, and minus 4 over n the sum of I, and then minus 9 the sum of 1. Let's do this together one more time. So I took out 2 over n, which is the constant in front of f of xi. And then when I apply the sum to 8i cubed over n cubed, the piece that does not depend on I, which is also a constant, a factor, I took it in front of the summation notation, just to save a little bit of time. And here I had 4 over n outside and the sum of I. And 9 is the same with 9 times 1. So that's why I was allowed to put 9 in front and then the sum of 1. Is this okay? So now we replace this and this and this. Don't cross it out like that. I'm just making a point. The last one is n. This one is n plus 1 divided by 2. And this one is the same but squared. n plus 1, so n squared, n plus 1 squared over 4. Is this better so far? So this is limit as n approaches infinity, 2 over n, and let's see what we have in brackets. We have an 8 over n cubed times an n squared, n plus 1 squared, divided by 4, and minus 4 over n, and n plus 1 divided by 2, and then minus 9n. Thank you for choosing this function. It's really nice. We're going to simplify it nicely. Is this okay? So I copied 8 over n cubed. I replaced this by n squared, n plus 1 squared over 4. I copied negative 4 over n, and I replaced the sum of I by n plus 1 over 2, and minus 9n. Agreed so far? Okay, so we'll continue. So this is limit as n approaches infinity. Now let's see. I will simplify an n squared with an n cubed. I will simplify a 4 with an 8. I will simplify a 2 with a 4. So the denominator will be just n. I will not simplify this n because I have the denominator n here. I have to have the denominator here and just multiply this one by n. So 2 over n multiplied by n in the denominator. I will have to distribute 2 to n plus 1 squared. Can anyone tell us what is n plus 1 squared? What does it equal to? N squared.
Plus 2n plus 1.
Very good. I'm going to distribute 2. So 2n squared plus 4n plus 2 minus 2n squared minus 2n and minus 9n squared. So let's do this one more time together. I distributed 2 to n squared plus 2n plus 1, and I got these three terms. Then I distributed negative 2n to n and negative 2n to 1. And then I had to multiply negative 9n by n because it did not have a denominator. Is this okay? Now, luckily, these two go away. So then we have that the limit as n approaches infinity. So I only have negative 9n squared at the top times 2, negative 18n squared. And then these two, positive 2n and then positive 2, and I forgot to distribute 2. So I have 4 and 4. So one more time, I had negative 9n squared and I distributed 2. Then I had 2 and I have to distribute 2. And then I had 2 and I had to distribute 2. Can anyone give us the area under the graph, or in this case, above the graph, of the function x cubed minus 2x minus 9?
The negative 2.
I will show you a different technique today, which is called the integral, the definite integral. So we're going to come back and check these answers with the other method. Any questions? Okay, I can continue chapter 5 before I go back to 4.9 that we skipped. So I have to go back. We have to go back to 4.9, anti-derivatives. What is the antiderivative? It's the function whose derivative is given to us. There are two notations. Extremely important notation. If we are given f prime or f double prime or triple prime, whatever, we are asked to find f of x. And the notation is lowercase f. So we're given some derivative or derivatives, who knows? I'll show you a few examples, we'll see in a moment. And we're asked to find the function whose derivative is f prime. Now we can be given, so if we are given f, then we are asked to find, very important, uppercase f of x. And you can say, what's the big deal? You're still going backwards. You're not differentiating, but you are basically integrating, going backwards. What's the difference between these two? Very important difference. This is specifically a specific notation for the fundamental theorem of calculus in chapter 5. So if I'm given f and I'm asked to find the antiderivative, I have to use the notation f, uppercase f. If I'm given f prime, f double prime, whatever, a derivative, then, and I'm asked to find the function, then I have to use the notation f of x. Okay? Good. So now the question is, which function, I just picked x cubed, which function has a derivative that is x cubed? So for example, I'm given f prime of x equals x cubed, and I'm asked to find f of x. Yes?
It has to be n minus 1, I'm sorry, n plus 1.
Very good. 3 plus 1 divided by 3 plus 1 plus a constant c. This function is the most general. I have to simplify it a little bit. In a moment I will. The most general antiderivative of x cubed. Antiderivative of f of x equals x cubed. So it will be f of x, x to the fourth over 4 plus a constant c. How do I check? Well, if I differentiate this, I bring 4 down, which will cancel or simplify, and I get x cubed. And when I differentiate the constant, I get 0. So what is the formula then? So if I want to find the most general antiderivative of x to the nth, please.
You could kind of the inverse of the power rule. You do x to the n plus 1 over n plus 1 plus c.
This is the most general antiderivative of function x to the nth. What does this mean? It means that I have infinitely many functions whose derivative is x to the n, because c can be any number. So there are infinitely many answers. However, sometimes we will be given specific conditions that help us determine just one function. So let's practice this before we do anything else. So this is at the end of chapter 4. So on page 349, let's look at a few examples. Let's start with 39. We are given the second derivative, which is -2 plus 12x minus 12x squared. And we are told that f of 0 is 4 and f prime of 0 is 12. It says find f. And of course the notation is uppercase or lowercase.
Uppercase.
Because we are given derivatives. Good. Okay. I cannot determine just by having the second derivative, I cannot determine the function. I have to go through an intermediate step, which is yes, finding f prime. Very good. Which function prime is -2? -2x prime is -2. Agreed? Plus 12 is a constant. Which function prime is x? Very good, over 2. Minus 12. Which function prime is x squared? X to the third divided by 3 plus a constant c that we will determine right this moment after I simplify this a little bit. So f prime of x equals -2x plus 6x squared minus 4x cubed plus a constant c. But I am given a piece of information. I am told that f prime of 0 is 12. Why do you think we're given this? To find c. So then if f prime of 0 equals 12, 0, 0, 0, c must equal 12. Is that correct? F prime of 0 is c, which equals 12, so then c must equal 12. Okay, so now I have the first derivative. I'm going to rewrite it. So f prime of x equals -2x plus 6x squared minus 4x cubed and plus 12. And now I'm ready to find f of x. Which function prime is -2x? It's -2 times plus 6 times x cubed over 3 minus 4 x to the fourth over 4 plus 12x plus a constant d, not to be confused with the previous one. Some books present C1 and C2. It doesn't matter. You can use any letter you want. So I will simplify it now. F of x equals negative x squared plus 2x cubed minus x to the fourth plus 12x plus d. But we are also given a piece of information that f of 0 is 4. And that will help us determine the constant d. So then, which is now the unique function, and I'm going to arrange it in descending order. Negative x to the fourth plus 2x cubed minus x squared plus 12x and plus very good. This is the unique or the only function that has the given second derivative and at the same time fulfills the two given conditions that f of 0 is 4 and f prime of 0 is 12. Is this clear? Okay, let's look at another. Let's say 45. Again, we are given the second derivative, and this is 2 plus cosine x. And we are told that f of 0 is negative 1, and f of pi over 2 is 0. Okay, so let's find this first derivative first. Which function prime is 2? Very good. Which function prime is cosine x? So plus sine x plus a constant c. I'm going to call it c1 now. Do I have any piece of information about f prime? I don't. So I have to proceed. So let's find f of x. Which function prime is 2x? 2, exactly. X squared over 2. And then which function prime is sine x? Plus, which function prime is c1? C1x, very good. Plus c2. This is good, but it's not good enough. Now I have two pieces of information. I'm told that this function evaluated at 0 will return negative 1, and evaluated, at pi over 2 is 0. Why are we given these two conditions?
First solve for C2, then for C1.
Correct. And find C1 and find C2. Very good. Perfect. So let's do just that. So we are told that f of 0 is negative 1. Then what does this mean? So 0, how much is cosine 0?
1.
Very good. So negative 1, c1 times 0 will be 0, plus c2 equals negative 1. How much is c2?
0.
It happens that c2 in this case is 0. So now the function is f of x equals x squared minus cosine x plus c1x, because c2 is 0. And now I have to use the other condition, f of pi over 2 is 0, in order to determine c1. So let's plug it in. Pi squared over 4 minus cosine pi over 2. Perfect. Plus pi over 2x equals 0. Oh, pi over 2 c1, I'm sorry. I plugged in x. Pi over 2 c1 equals 0. I move pi squared over 4 to the other side. So pi over 2 c1 equals negative pi squared over 4. And I have to get rid of pi over 2. What should I do to both sides to get rid of pi over 2 and solve just for c1? Yes, or multiply by 2 over pi. Very good, awesome. So then C1 equals, I simplify one of the pi's, and I'll simplify it too. So this is negative pi over 2. Now I can write the entire function, f of x, x squared, minus cosine x, minus pi over 2x. There is no other function whose derivative is 2 plus cosine x, second derivative is 2 plus cosine x, and fulfills the given conditions. F of 0 is negative 1, and f of pi over 2 is 0, but this one. Any questions?
In the book,
Yes.
I accidentally did the antiderivative chapter a little bit, but in the book there was one problem where it left out. It didn't have you add on a variable to one of the constants when you did the antiderivative, like in the answer.
So can you tell me which one? That would be, I'll give you the book.
It would have been,
That would be great to see what you're. Oh, you have a book.
yeah, but I don't have. I only put in whatever chapter we're on.
Sure.
So,
Sure, of course.
I
Yeah, I'd like to see what that is. Very good.
think they made a mistake. But
It's possible.
I can't remember what the book.
Was it in 4.9?
Yeah. Figure it out pretty quick. I think it was. It was either. I'm gonna say it was 21 on page 348. I don't think that's it.
It is? You think it is?
I don't think so, but it's either this one or that one, maybe
27?
27.
Oh, they did not determine C and D, you mean?
I can't remember now, but
So,
I just know that when you did the antiderivative, they didn't include x with one of these, and there's a term d as well. I'm not sure which.
can you bring it next Tuesday then?
Yeah,
Because I'd like to see what it is.
I just can't remember.
That's fine. Okay. Do we think we need another example? Maybe with the velocity and acceleration? Okay, so let's take a look at 61 on page 349. And A of t, 2t plus 1. S of 0 is 3, V of 0 is negative 2. We are given the acceleration. We're asked to find the distance. And we are given, in addition to the acceleration, we are given two pieces of information. That the distance at 0 is 3 and the velocity at 0 is negative 2. How can I go back from the acceleration to the distance? I have to find v of t first. Good. Which function prime is 2t? So 2t squared over 2, and I will simplify that, plus which function prime is 1? T, very good, plus a constant c1. But I know that v of 0 is negative 2, so I'll simplify v of t as t squared plus t plus c1. So I'm told that v of 0 is negative 2. That makes c1 what? Negative 2. So then the velocity is t squared plus t minus 2. Now we are ready to determine the distance formula or displacement. Which function prime is t squared? Very good. plus t squared over 2 minus 2t plus a constant c2. But we are told that s of 0 is 3, which means that c2 is 3. So we determine the only function whose acceleration is given and fulfills the two given conditions. T cubed over 3 plus t squared over 2 minus 2t and plus 3. Any questions? Any questions? Now we can go back to chapter 5. Do we need more examples?
Yes, one question I would have.
Yes.
Are there any rules that apply only to antiderivatives and not, like, for instance, there are the, like the power rule, the law of multiplication?
Very good question. Very good question. For multiplication, you have to wait till Calc 2 because you're going to use integration by parts. Very good question. Then you asked the product. The ratio, the same thing. It depends on the type. It depends on the function. You may have to wait till Calc 2 for partial fraction decomposition.
Okay.
For ratios. For power, it depends on what power and what function. Very good question. We will discuss, hopefully today, if we get to that, the substitution rule. So again, I have to see the function that the integral is applied to. But for the product, unless we can use the substitution rule, you have to wait for the integration by parts. For ratios, unless we can do something with the substitution rule, then you have to wait for the partial fraction decomposition in Calc 2. So this is exactly the chapter right after applications of areas, distance, and volumes. So all the techniques of integration, other than what we are doing here. Very good question. Thank you. Okay, so where was I? So we were looking at the antiderivatives. Now, why do we need this? Why did I have all of a sudden to stop and say, stop, we have to do this before we continue? Here's why. So if we look at a continuous function, it must be continuous function f of x. Let's say on the interval a comma b. And let's suppose we want to determine this area. If the function is linear, quadratic, or cubic, I have a way. It's called the limit of the Riemann sum. But otherwise, for general functions, I won't be able to do this. So there is another way of determining this area. And of course, it's the same idea, meaning I divide the interval into n subintervals, and the width of each subinterval will be, if you remember the notation delta x from differentials, it's the same with the notation dx, the same measure. So it's the same idea. I will have to divide the interval into n subintervals. I will have the width of which subinterval and then multiply it by the height, right? So if I want to just show one interval, then this will be dx, and the height of the rectangle will be f of x. If I get now to this interval, the base will be delta dx, and the height will be f of x. So the same thing. Okay. So now what happens is we are no longer using this notation for what I'm going to call in a minute the definite integral. So this is the sigma notation for the limit of the Riemann sum. But now we're going to use s, the Latin s. However, we're going to stretch it vertically. but that's all it means. It's the sum of areas of f of x dx. One more time, base times height plus base times height plus base times height. But of course, this is from the interval, from the lower limit, which is a, till the upper limit, which is b. Okay, so let's say, number one, that the integral from a to b from f of x dx, remember, is the same with the limit of the Riemann sum. It's identical, so I'm going to write it now. It's the limit as n approaches infinity from I equals 1 through n from delta x f of xi. They are identical. They will always give us the same number. This is called definite integral. A is called the lower limit. What do you think B is called? Very good. So now what is the technique? We showed the technique of finding the limit of the Riemann sum, but we were limited to linear, quadratic, and cubic. But what is the technique for this? How do I determine this? For some functions I can, not for all of them. But way more than for this. For this is just 3 different functions. For this, way more than just 3. But even then, even with this, I'm somewhat limited. Okay, so let's discuss the technique. First of all, f of x must be continuous on the interval a comma b. If it's not continuous, we are not going to be able to use this technique. We have to wait till Calc 2 for improper integrals. Okay. So how do we determine this? Here it is. It's called fundamental theorem of calculus, part 2. In some books, it will be part 1. In your book, it's part 2. It doesn't matter. But this part, it will teach us how to evaluate definite integrals. So it shows, this is more important than calling it part 1 or part 2. It shows how to evaluate a definite integral. Why is it called definite? Because it has limits of integration. That's why it's called definite.
Test message. This is a test of the ACW emergency notification system. This is only a test.
It shows how to evaluate a definite
Test
integral.
message. This is a test of the ACW emergency notification system. This is only a test.
Okay.
Test message. This is a test of the ACW emergency notification system. This is only a test.
Okay, so what did we say about the antiderivative of a function denoted by lowercase f of x? How do we denote the antiderivative of f of x? Very good. So, the definite integral of f of x dx. Remember, this is the delta x and this is the function, exactly like we had in this limit of the Riemann sum. Base times height, base times height, is the most general antiderivative of function f of x, evaluated from a to b, which is also f of the upper limit minus f of the lower limit. This is the fundamental theorem of calculus part 2 that shows how to evaluate a definite integral. So now let's go back to any of those integrals that, any of those areas that we just determined. Give me the previous ones. Any of the previous ones so we can check. So we had a function that was, if I remember correctly, x cubed
Minus 2x.
minus
9.
minus 9. And the answer that we got was negative 18, I think. Good. And the interval, I think it was 0, comma 2, correct? Okay. How do I find the area now? Can anyone dictate?
Draw the S.
Yes?
with a
The
0.
stretched s, very good, from 0 to 2, the integral from 0 to 2, from, in parentheses, x cubed minus 2x minus 9. I have to have dx. There is no integral without dx or dt, whatever the variable is. Good. So now let's find the antiderivative of this, as we learned from section 4.9. Which function prime is x cubed? Well, the answer is x to the 4 over 4 minus 2 x squared over 2 minus 9x, put everything in parentheses, evaluated from 0 to 2. The fundamental theorem of calculus is requiring us to put in 2 first and subtract when I put in 0. But lucky me, when I put in 0, what do I get? All zeros, correct. So let's plug in 2, just 2. So 2 to the 4th is 16, 16 over 4, these two go away, minus 4 and minus 18. But 16 over 4 is, and 4 minus 4 is, so the answer is indeed negative 18. And now I just want to sound funny. Is this easier than the previous one? Any questions?